All right, hey guys, we are here ready for our review quiz for lessons 4.1 to 4.5. We are going to be looking at how many groups, seeing which one is closer to 1, smaller than 1, greater than 1. Our I can statement is that we can explain how division can be interpreted and to analyze the context of a division problem and tell how many groups or how many are in each group is the goal for this quiz this week. So, without further ado, questions 1, 2, and 3 we need to decide on without computing, so no computation. Decide if this answer is going to be smaller than 1, close to 1, or larger than 1, and explain why. So here on question number 1, we discussed that if we could write this as a fraction, we would be able to see it a little bit easier. So if I write this 80½ divided by 79, I'm going to say that 80½ is close to 80, okay? And if I say 79 is close to 80 as well, I can say that 80 divided by 80 is going to be 1. So my answer to this one is going to be close to 1 whole. On question number 2, 60 divided by 2, we're going to write that as a fraction. 60 divided by 2. I can tell that this is an improper fraction because my numerator is greater than my denominator. So this is an improper fraction. And by looking at this, I can say that 2 goes into 60 30 times. So I know that my answer is going to be greater than 1. On question number 3, we have 12 divided by 1,200,000. Well, in order to get to 1 whole, if it's going to be close to 1, then my numerator needs to be close to 1 million. My numerator is much less than 1 million. Therefore, my fraction or my division problem is going to be much smaller than 1. Okay, let's head down to question number 4. On question number 4, write all of the multiplication equations that go with this division equation. You do not have to solve this problem, but if you did solve the problem, you could go back to check your work by doing the actual computation. So 15 divided by 2½ is going to equal something. Well, the opposite of division is multiplication, so I'm going to have to work backwards, or the inverse operation. So question mark times 2½ is going to equal 15. Again, I could do fact families here, and we can reverse the order of our numbers. So we have 2½ times question mark is going to equal 15. So those are my 2 multiplication equations that I could go back to check. If I wanted to look at a division equation that would see if it's going to work, we would do 15 divided by question mark equals 2½. So here, that would give us one more way to look at this equation. Even though it doesn't ask for a division problem, that will help us to see that it could be written one other way. Number 5, write a division or multiplication equation that represents the situation. We do not need to solve this equation. We just need to write either a division or a multiplication equation. I will show you all the ways that it could be solved. A large piece of string is 56 inches long. So we're talking about this is my total amount. And it is cut. When I cut something, I'm dividing it up. So it's cut into 7 smaller pieces. How long is each piece of string? So we want to know how long each piece of string is going to be if I have 7 pieces of string. So my division problem I think of is 56 divided by 7 equals question mark. I could think of it this way as something times 7 has to equal 56. And another way I could think of it is 56 divided by question mark has to be 7. And I could do the inverse operation and do 7 times question mark is going to also be 56. If it's easier to draw a picture to see what the picture is, we could draw a picture and say that I have 7 pieces of string. That would be 3, 4, 5, 6, 7 pieces of string. And the total of this string has to be 56 inches. So the whole thing is 56 inches. And that's going to help us to be able to see that each piece is going to be 8 inches long. So sometimes if we draw a picture, it helps us to understand what we're actually talking about here. All right, our next piece. Number 6, Alex poured 48 ounces of Cheerios into 10 bowls. I love me some Cheerios. 48 is my total amount of Cheerios, and I want to put them into 10 bowls evenly. In all of the bowls, if all of the bowls have the same amount of cereal, how many ounces are in each bowl? So that means I'm going to be doing some division. I'm going to take 48 divided by 10. Remember, I can write it as a fraction, 48 over 10. So here I would do my division, 48 divided by 10. 10 goes into 4? No. 10 goes into 48 4 times. 4 times 10 is 40. Subtract, I get 8. I could make this into a fraction and say this would be 8/10. So each bowl would have 4 8/10 ounces of Cheerios. Or I'm going to go back to my division problem, 48 divided by 10. 10 doesn't go into 4, but it goes into 48 4 times to give me 40. Subtract, I get 8. From here, I could put this as a decimal and a 0. Bring it on down. 10 goes into 88 times. Subtract, we get 0. And that decimal point is going straight up. So now I have written it both ways, as a decimal and as a fraction. Number 7, the hexagon represents one whole. Draw a pattern block diagram that represents the equation 3 divided by 1/2 equals 6. Well, remember, if I'm going to solve this, this is really saying 3 over 1 times the reciprocal 2 over 1 equals 6 over 1, which is 6 whole. Okay? This picture that we're drawing has to represent 3 whole, so I'm talking about my hexagon. So if I draw my hexagon 3 times, that would give me 3 whole. There's 1 whole. Here's 2 whole. Oops. And 3 whole hexagons. That's 3 whole. And remember, we're dividing them in half. So I'm going to divide it in half, divide in half, divide in half. How many parts do I have now? I have 1, 2, 3, 4, 5, 6 groups of halves would make a total of 3 whole. The number 8. The hexagon represents one whole. Draw a pattern block that represents the equation 11 times 1/6. So we have 11 times 1/6. We put our 1 under our whole number, and we multiply straight across. 11 times 1 is 11. 1 times 6 is 6. When I divide 11 divided by 6, it goes in 1 time. That would leave 5 left over. 5 becomes my numerator, 6 stays my denominator to get 1 and 5, 6 right here. So when we talked about this, when we did this on our Chromebooks with our pattern blocks, we said that 1/6 represents my triangle. So my triangle represented 1/6 of the hexagon. This represents 1/2, and this was 1/3 of our hexagon. Our hexagon is one whole. So if I look at this and I draw my pattern blocks, and I have 1/6 11 times, I'm going to have 1/6, remember 11 times, so right here, 1/6, 1/6, 1/6. Remember 6, 6 equals this one whole, and we need to do 1/6 times 11. So I need to do 5 more, because I only have 6. 1, 2, 3, 4, 5 more. So that would give me my 5/6. So we have 1 and 5/6. And you can see that this part is left out of the whole. We needed one more 6 to make a whole. So that is our answer, 1 and 5/6. Number 9. A grocery store sells apples in 3/5 pound bags. 3/5 pound bags. A customer bought 6 pounds of apples to make applesauce. Bracket, how many bags did he buy? So if I just need a visual, I can draw a picture, and I could say that this is 3/5 of a bag. And if I drew another picture, I would say this would be 3/5 of a bag. If I combine these together, that would give me 6/5 or 1 and 1/5 of a bag. That just kind of gives me thinking about what the question is asking. So I have 6 pounds of apples divided by 3/5 pound bags. So we have keep, change, reciprocal. And now we're ready for our problem. I can cross simplify here. 3 goes into 3 once. 3 goes into 6 twice. And when we multiply straight across, 2 times 5 would be 10 over 1. Anything over 1 is itself, so we would need 10 bags of apples. Or 10 bags of 3/5 pound bags of apples. Okay? Number 10. A recipe uses 8 cups of water for every 3 cups of sugar. So I would draw my T-chart like we had done back before the winter break, and we have water and we have sugar. You could also do a double number line if you choose. If we have 8 cups of water to 3 cups of sugar, I can see here that I need to know how much water is used for 1 cup of sugar. So my 1 is going to have to go right here. All right, I'm going to pause and I will come back in just a moment.